As I said in the previous video, completing the square is not how I would solve a quadratic equation that has irrational solutions. Instead, I would use the quadratic formula. I used to make my students memorize this until all of a sudden the ACT started putting this formula on the test. But if you want to remember this formula, I think it's a cute little formula. There's a little song that goes along with it. As long as your equation is in the form ax squared plus bx plus c equals 0, then you can remember the quadratic formula by singing a song that goes along with Pop Goes the Weasel. And it goes like this. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And it seems kind of a weird little song, like why would I sing a song to remember a formula? But you'll remember, trust me. When I use the quadratic formula, this is how I attack the problem. First, I determine what a, b, and c are. Be careful. If there's a minus sign in front of a number, remember that it makes it negative. So in the equation 3x squared minus 5x minus 1 equals 0, a is 3, b is negative 5, and c is negative 1. Then I go plug it into the formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Watch those double negatives. It's always the opposite of b. So if b is negative, it becomes a positive, doesn't it? And if b is positive, it'll become a negative. So when I simplify this, I simplify this first. And then I simplify what's underneath the square root sign. Negative 5 squared is 25, and 25 plus 12 is 37, and that's all over 6. This answer will be irrational, and the reason that I know it'll be irrational is because 37 is a prime number, and if it's a prime number, its square root's going to be an irrational number. Remember, an irrational number is a non-repeating, non-terminating decimal. So it's easiest to just leave the answer just like this. If you want to turn them into decimals, you can. So if you want to do 5 plus the square root of 37 and divide it by 6, you should find out it's approximately 1.8471. And then 5 minus the square root of 37 divided by 6 is approximately negative 0.1805. You could actually find these decimal equivalent answers on the graphing calculator by putting the original equation into y1 equals, graph it, and when you graph it, you'll notice that one of the x-intercepts is between 1 and 2, and the other x-intercept is between 0 and negative 1. The solutions to a quadratic equation, other than be called roots or solutions, we also call them zeros. So if you go to second trace, you'll notice that option number 2 is called 0. If you pick that one, the bottom of the screen will say left bound ? Well, in order to find this 0, you want to pick the integer that's to the left of your 0. So 1 would be my left bound, and I would just hit 1 and enter. Now it should say right bound ? Well, 2 is to the right of my 0. So I would type in 2 and hit enter. Then it says guess ? Just hit enter a third time, and the x value at the bottom should say 1.8471, and there may be some other numbers. To do the second 0, you would go back to second trace and number 2 a second time. But this time, this would be the left bound, because negative 1 is to the left of my 0, and 0 would be my right bound. Remember, when it says guess, hit enter a third time, and then the answer at the bottom of the screen should come up as negative 0.1805. Let's do this again. For 4x squared plus 12x plus 9 equals 0, a would be 4, b would be 12, and c would be 9. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And then I simplify this in parts. So I have negative 12 plus or minus the square root of 144 minus whatever 4 times 4 times 9 is going to give you 0 over 8. Well, what's the square root of 0? The square root of 0 is just 0. So it turns out the answer is just negative 12 over 8. That means this quadratic equation only touches the x-axis one time. And the one time is at negative 3/2 or negative 1.5. Whereas this particular equation hit the x-axis in 2 locations. There are 3 things that can happen when you solve a quadratic equation. It could hit twice, it could hit once, or it may not hit the x-axis at all, in which case we say it has no solution. So now let's look at this third example. X squared plus 2x plus 2 equals 0. A would be 1, B would be 2, and C would be 2. X equals the opposite of B plus or minus the square root of b squared minus 4ac all over 2a. So when I go simplify this, I get negative 2 plus or minus the square root of negative 4 all over 2. Wait a second. The square root of negative 4, we may remember from Algebra 2 that that's something called an imaginary number, and the answer is actually 2i. But if we're just talking about real numbers, if you graph the original equation, it never touches the x-axis. If the graph never touches the x-axis, we say it has no real solutions because it has imaginary solutions. We'll come back to imaginary numbers at another time. The expression that's under the square root sign in the quadratic formula is known as the discriminant. The discriminant is important because it'll tell you how many and what type of solutions you have before you ever do the problem. So if b squared minus 4ac is greater than 0, you're going to get 2 real solutions every time. If b squared minus 4ac is equal to 0, you're going to get 1 real solution. That means the graph hits the x-axis one time. And if b squared minus 4ac is less than 0, that means it's a negative, you're going to get no real solution because the graph never touches the x-axis. So in this example, if I wanted to figure out how many solutions my equation has, I could just find the b squared minus 4ac part. Well, b is 4, a is 1, and c is negative 1. I'm going to find out the answer here is 20. Well, it's greater than 0, so it must have 2 real solutions. How about 4x squared minus 12x plus 9 equals 0? And again, don't forget that your quadratic equation has to equal 0. If it doesn't, you must make it equal 0 before you try this. All right, so b squared minus 4ac is going to give me 0. Well, if I get 0, that means there's 1 real solution. We're going to try this one more time. You probably know what the answer is going to be before I do anything. All right, so b squared minus 4ac, and all I'm going to do is just shove it in my calculator. When I shove it in my calculator, I get negative 1.3 repeating, which is the same as negative 4/3. And since I got a negative, there's no real solution. In Algebra 2, we spent a lot of time talking about these application problems of quadratic equations called the path of a projectile. An object thrown or fired straight upward at an initial speed of v0 feet per second will reach a height of h feet after t seconds, where h and t are related by the formula h of t is equal to negative 16t squared plus v naught t. Suppose that a bullet is shot straight upward with an initial speed of 800 feet per second. When does the bullet fall back to the ground? Well, first of all, this is your v naught. That's your initial velocity. And you may remember from physics that v naught is your initial velocity. And we want to know when the bullet will come back to the ground. So we want to find time. Well, when it hits the ground, what's its height above the ground? Its final height would be 0. So we really want to solve this equation. There are two ways of doing it. One way is to use the quadratic formula. I actually think that the easiest way to solve this problem is to do it this way, which is a little bit different from the way so when you get the textbook, this section does the problem a little bit different. I like to factor out a t. And then I like to use the zero product property. So the zero product property says that when time is 0, the height is 0. Well, that's great. That means I didn't shoot the bullet. The other equation is negative 16t plus 800 equals 0. And I would solve that for t, and that would tell me when it's going to hit the ground again. So negative 16t is equal to negative 800. Divide by negative 16, and you find out that t is 50. So the bullet will hit the ground again in 50 seconds. The next part of the problem is to figure out when this projectile does reach a height of 6,400 feet. That means, when's its final height 6,400? So we want to solve 6,400 is equal to negative 16t squared plus 800t. This is one where I would actually use the quadratic formula, or factoring if I'm good at factoring. However, I'd probably just use the quadratic formula for this one. In order to do that, I need to set the equation equal to 0, which means that I need to subtract the 6,400, A, B, C. So in this case, it's not x, it's t equals the opposite of b, plus or minus the square root of b squared minus 4ac. Sorry, it's getting a little sloppy. I gotta change my stick here. All over 2a. So when I simplify, I get negative 800 plus or minus the square root of 230,400 all over negative 32. Now, since we're solving for t, here's a little thing about t. T has to be positive. You can't go back in time, so t can't be negative. So when I do negative 800, we're going to do just plus the square root of 230,400. And then we're going to divide that answer by negative 32. And we're going to find out that t is 10. So it's going to take 10 seconds to get to 6,400 feet. The reason I didn't do the second equation, remember the quadratic equation actually has two solutions. The other one would theoretically be negative 800 minus the square root of 230,400. Actually, I am doing that because I forgot I'm dividing by a negative, so I should get a positive at the end. Let's see, negative 800 minus the square root of 230,400. And then I'm going to divide that answer by negative 32, and I find out the other answer is 40. Sorry about that. So in its motion, projectile motion, remember, looks like this. It's going to hit 6,400 feet twice. The first time it's going to hit is at 10 seconds on the way up. And then on the way down, it's going to hit it at 40 seconds. Remember, when you work with an equation, you have to work in consistent units of measurement. So in problem C, when does it reach a height of 2 miles? You cannot plug in 2 for the height. You have to change that back into feet. There are 5,280 feet in 1 mile. This is something that we hope you have memorized. It will pop up many times during the school year. So 5,280 times 2 is 10,560. So we want to know, when is my projectile, my bullet, going to hit 10,560 feet? So we're going to do 10,560 is equal to negative 16t squared plus 800t. And again, I prefer doing this using the quadratic formula. So what I'm going to do is I'm going to do negative 16t squared plus 800t minus 10,560 equals 0. This is A, this is B, this is C. When I go plug this into the quadratic formula, I'm going to get t equals the opposite of B plus or minus the square root of b squared minus 4ac all over 2a. And then I'm going to simplify this in parts. So I'm going to get negative 800 plus or minus the square root of negative 35,840 all over negative 32. Wait a second. Isn't that a negative under a square root sign? That means I have no real solution. That means that this bullet doesn't actually ever get to 10,560 feet when you shoot it into the air. In the projectile motion of this bullet, there is a maximum height that the ball will reach. To find the maximum height, again, I'm going to do this different from the way the textbook does it. I'm going to do it in the way that you learned it in Algebra 2. We learned that the opposite of b over 2a is the equation of the axis of symmetry, that line that goes through the middle of the parabola, but it also is going to tell us the x-coordinate of the maximum or minimum of the parabola. Well, for projectile motion problems, we're always doing upside-down parabolas, so they will always have maximums. And instead of x, we're using t. So in this equation, h of t is equal to negative 16t squared plus 800t. B is 800. A is negative 16. So negative 800 divided by negative 32 is going to be 25. So at 25 seconds, the bullet will hit its maximum point. But the question is, what is its maximum point? To find its maximum point, all you have to do is plug 25 back in for t, and then shove it into your calculator. And you should get an answer of 10,000 feet. So the maximum height it hits is 10,000 feet, which meant that in the previous problem, 2 miles was too high. There are other types of equations that we'll run across, other than the general linear and quadratic. For example, this is a rational equation. 3 over x plus 5 over x plus 2 is equal to 2. The way we learned how to do this in Algebra 2 was we would find the least common denominator. Well, if the denominators are x, x plus 2, and 1, the least common denominator is x, x plus 2. I just didn't put the times 1 because what's the point? So the first fraction needs an x plus 2. The second fraction needs an x. And the third fraction needs both. When you do that, the denominators become something called negligible. Negligible means they don't matter. So that's why I didn't write any of the denominators. Well, now this is just an equation that I have to distribute. It's going to be quadratic because there's a 2x squared. And since it's quadratic, I'm going to get the equation equal to 0. So in order to get it equal to 0, I can combine these to get 8x. And then I can subtract 8x over here. And I get negative 4x. And then I can subtract the 6 from the other side. So I end up with 0 is equal to 2x squared minus 4x minus 6. One way of doing this, you can graph it, find where it hits the x-axis. You can put in the quadratic formula You can notice that everything is divisible by 2, which means that this no longer matters, and I can easily factor x squared minus 2x minus 3 into x minus 3, x plus 1. And using the zero product property, I find out that x is equal to 3 and x is equal to negative 1. Now, in this particular problem, because the original problem had x's in the denominator of a fraction, you have to go back and you have to check these solutions with the original problem. But all you have to do is ask yourself, does either 3 or negative 1 make any of the denominators 0? Because if it does, then the solution is called extraneous. It means that you got an answer, but it doesn't make the original problem true. And neither 3 nor negative 1 makes either of the denominators with x's 0, so we don't have to worry about them. You may also remember equations that look like this from Algebra 2. This is called a radical equation. In order to solve a radical equation, the first thing that I'm going to do is I'm going to isolate the radical. That means get the radical to be all by itself. So first I subtract the 1. However, there's still a negative 1 being multiplied in front of the radical. Well, I'm going to get rid of it by dividing or multiplying the other side by negative 1. If you don't like negative 2x plus 1, you can write that as 1 minus 2x. That might make it look a little bit nicer. Once you've isolated the radical, we get rid of square roots by squaring both sides. But you have to be careful. You have to square the side, not each individual term. So on the left-hand side, you're really doing this. When you FOIL it, you'll get 1 minus 4x plus 4x squared. And when you square a square root, they go away. Well, again, I'm left with a quadratic equation. I'm going to rewrite this so it's in descending order of power. So I'm going to get 4x squared. Then I'm going to add this x. So I'm going to get minus 3x. And then I'm going to subtract this 2, so I get minus 1. Since this particular quadratic equation has a leading coefficient other than 1, you can either factor by grouping, or you can use the quadratic formula. Most students find the quadratic formula a little bit better way of solving this problem other than trying to factor by grouping, which can sometimes be a long and drawn-out process. Your other option, though, is you could always graph it and find the solutions. They're both rational. So what I'm going to do is I'm going to do x is equal to the opposite of b is negative 3, plus or minus the square root of b squared minus 4ac all over 2a. So I get 3 plus or minus the square root of 9 plus 16 is 25 all over 8. So my two solutions are going to be 3 plus 5 over 8, and the other one's going to be 3 minus 5 over 8. So 8 over 8 is 1 of the solutions, and negative 2 over 8 is negative 1/4. If you were to have graphed this, you would have seen the graphing calculator hit the x-axis at positive 1, and you would have seen it hit between 0 and negative 1, and you could have used the 0 function on the calculator to find it. When dealing with a fourth degree equation of quadratic type, that means that the first term is x to the fourth and the second term is x squared. What we do is we pretend like it says this, and then we solve the equation. It's just that after we're done solving the equation, we're going to, instead of making it equal to x, we're going to make it equal to x squared. And the reason that happens is because really we're doing this. I think I'm writing this right. If I'm not, I apologize. All right, then I would use the quadratic formula to solve this. X is equal to the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a, which is 8 plus or minus the square root of 32 over 2. The square root of 32 factors into 4, the square root of 2, and then both of these are divisible by 2. 4 plus or minus 2 radical 2. But that's not what x is equal to, that's what x squared is equal to. So how do you get x? You pull this trick off. There are probably more complicated answers. We're going to leave it like this. There are actually 4 answers to this problem, but we won't run into one this complicated. Absolute value equations are again equations we ran into in Algebra 2. Absolute value equations, the ones whose graphs were v's, gave you 2 answers. And the way we found them was we would take what's between the bars and set it equal to 3 because the absolute value of 3 is 3. But we would also take what's between the bars and set it equal to negative 3 because the absolute value of negative 3 is also 3. That's why there are 2 solutions. Well, now these are simple linear equations. So 2x is equal to 8, so x is equal to 4. And 2x is equal to 2, so x is equal to 1. Although we probably won't run across a problem that looks like this, we always like to think about how we attack problems we don't know how to do. So how would we attack a problem with fractional powers? Well, we only know how to solve these equations if they have integer exponents. And particularly, this kind of looks like it wants to be quadratic. I really want it to be quadratic. So in order for this to actually say x squared, I would have to make this x to something else to the 1/3 power. Well, in order to get this to say the 1/3 power, actually I should get rid of this. I want to, square this so that I get the 1/3 power, and this is where I would get the 1/3 power. So we're going to use this in a minute. So I'm going to rewrite this as x squared plus x minus 2 equals 0. Because that's a problem I do know how to solve. So I could factor that into x plus 2, x minus 1 equals 0. So x is equal to negative 2 and x is equal to 1. Except I don't really want it to be x. I really want it to be x to the 1/6 equals negative 2 and x to the 1/6 equals 1. Where did the 1/6 come from? It came from here. How do I make x squared into x to the 1/3 power? So, we've already talked about how you solve these. To get rid of a 1/6 power, you raise the other side to its reciprocal. Well, 1 to the 6th is easy because it's just 1. Negative 2 to the 6th power is going to be positive 64. And again, if you're not sure if those should be the right answers or not, double check them in the original problem to see if they work.